Alright, the two things we're going to talk about in this video are going to be sectors of a circle. So we know that the area of a circle is going to be equal to the radius squared times pi. So A r2 pi. Remember, with that being, the radius is a line from the center of the circle all the way to the outside of the circle. What we're going to talk about is a sector of a circle, which, like we talked about in class, is like a slice of the circle. And if we're talking about the sector area, then we want to find how much area that section of the slice or that sector takes up. And really the formula is very similar to what the area of a circle is. If we give this some sort of measurement, let's say for my sector here, I've got a 60-degree angle. Alright. Now when we think about it, when we're talking about a whole circle, we're talking about 360 out of 360 degrees. So we're talking about the entire circle here. What we're going to do with a sector now is we're going to change that, so we're no longer taking the whole 360 degrees. So when I'm finding the area, I still take my radius squared, I multiply that by pi, and then instead of taking all 360 degrees, I only want to know what 60 of that 360 degrees, what that area of that sector is going to give me. The only other thing I'll need with this problem would be a radius, and for the time being, let's say we've got a radius of 3. So now I have everything I need to know. I've got my degrees, which is 60 degrees, and I can now plug in my radius. If I go through this problem, I'm trying to find the area. I would have 3 squared times pi over 60 over 360 is going to reduce down to 1/6. 3 squared is 9 times 1/6. If I want to simplify without actually multiplying, I could say that this sector is going to be equal to 9/6 pi, and we'll call it inches squared. Remember, since it is an area, it's going to be inches squared and not just inches. And really, to completely simplify here, what I would have to do is 9/6 times pi, which is 3.14. You can do those calculations if you wanted to, but what I'm worried about is that we can get to a form that looks like this. So we've got to understand now that we're only working with a sector of this circle, which is going to translate to us only using a portion of that circle when we're talking about the degrees. So instead of 360 degrees, we're going to use 60 degrees. So that's my sector area. If we look at an example of that, I've got a circle with EFG. So I've got EFG is this angle here, and it is 168 degrees. The length from E to F is 13 units, and I want to find the area of the sector EFG. So I want to find the area of this now larger piece of the pie. So I'm going to use my same formula. For my area of a sector, I want to use my radius squared times pi times whatever sector or section of the circle I have. Divide that by 360. Just got to plug and chug now. My radius was 13, so I got 13 squared times pi times x, which is 168 over 360. And if I pull out my calculator here, I can do a little bit of simplifying. 13 squared should be 169. multiply that by 168, and multiply that by pi. Divide this whole thing by 360. So if I do 169 times 168 times 3.14, get a big 89,000. Divide that by 360. My area here of just this sector would be 247.64, and since this measurement is in units, this is going to be units squared. So when I'm looking at area, I'm just finding the area of just a sector of a circle. Now along with finding sector area comes sector length. So if I wanted to look at that same original angle I had, my 60-degree angle, and we said my radius was 3 inches here. If I want to look at what my sector length is, that means I'm trying to find what the length of this part of my circle would be. Again, we're going to turn and look at what the entire circumference would be, which would be this circle around here. If I looked at the equation for that, I would see that the circumference is equal to 2 times r times pi. And now again, remember, that's for 360 of 360 degrees, because I'm talking about the entire circle. What's going to change now is my 2 pi r is going to stay the same. Now only since I'm using a section of the circle, I'm going to only account for 60 of the 360 degrees. So I've got my angle plugged in there. Do the same thing with my radius. I can plug that in for r. So I'll plug in 3 there. I'm going to get 2 times 3 times pi times 60 over 360. And this is going to be interesting. So I'm going to get, my circumference would be 6 times pi times 60 over 360, which is just going to reduce down. 6 times 60 is 360. 360 divided by 360 is 1. I'm just going to get pi. And remember, I'm talking inches here, so I'm just going to get pi inches, or 3.14 inches. Which means that this distance here, from this point to this point, is going to be 3.14 inches. And if we look at a problem for that, same kind of setup here. So I've got the angle KLM. Oops. Got my angle KLM here. And I know that is 92 degrees. My radius from K to L is 17 units. I'm trying to find the arc length from K to M, which would be from here to here. So I'm going to use my sector length formula, which is going to be 2 times the radius times pi times whatever degree I have out of 360. In this case, it'd be 92 out of 360. My radius is 17, so I can plug that in. 2 times 17 times pi times 92 over 360. Again, now all I got to do is pull out my calculator and do some plugging and chugging. So 2 times 17 would be 34, times 92 gives me 3,128. Multiply that by 3.14, divide by 360. I'm going to get a sector length of 27.28. And now, since I just have a linear measurement, a straight line measurement, it's just going to be units and not units squared. So that's the difference between our sector area, which is going to be an area of the circle, and our arc, or our circle, or I'm sorry, our sector length, or our arc length, which is just going to be a length of the circle.